In this lesson we will graph circles and parabolas. The focus will be on parabolas, no pun intended, and but we will review circles. So before we get started with this, let's look at where the equation of a circle comes from. Here is a point on the circle. This is any point, so I just label it with x, y, x being any value, any x value of a point on the circle. It could be anywhere on the circle. Wherever the point is on the circle, it has an x value and a y value, and then we have a right triangle, so we can use the Pythagorean theorem, and there's the equation of a circle. It's just the Pythagorean theorem. So then when we have a question like this, the center is at 3, 4 with a radius of 7, and one, 2, 3, 4, 5, 6, 7. So we have a circle with a radius of 7. To write the equation for this, we just have to have x minus the horizontal shift, y minus the vertical shift equals r squared. The radius is 7, and the horizontal shift is 1, 2, 3. The vertical shift is 4. And that's all we have to do for the equation of the circle. Pause the video and try that one. Center, negative 2, 7, and we're going to go down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we have a circle like that. So we just fill in the equation. The radius is 6. The horizontal shift is negative 2, and the vertical shift is 7. So we could write it like this. And that's just a quick review of circles. Now let's go to parabolas. So this is looking at the definition of a parabola. We have a point 0, 2, and we have the line y equals 0. And we want to find all the points, sketch all the points equidistant to these, to the point and to the line. So if we have a point right here, its distance to this point is 1, and the distance to the line is 1. As we move out, if we move right here, and we say this distance is not equal to that distance, so that's not one of the points that we want. And we're going to estimate if we have to try to make this distance should be equal to that distance. And it looks like it's approximately the same. If we have a point over there, then we would have a point on the other side where we have those distances are equal, being equal. As we move out, we can't move over here because we have a long distance and a short distance, so that doesn't work. We can't move here because we have a long distance here and a shorter distance there, so that doesn't work. And we have to have something where this distance looks like it's equal to that distance. This distance is equal to that distance, and that's approximately equal. If we have one on this side, then we'll have one on this side. And if we look at all the points that satisfy the equidistant requirement, then that's what a parabola is. And that is the vertex. This is called the focus, and this is the directrix. We have an equation of this parabola, well, not this parabola, but any parabola. We're going to write it like this. This is the horizontal shift. And that means that is the vertical shift. This is the distance and direction to the focus. In this formula, we'll always have a 4. And then we just have to remember that when x is squared, we have a graph opening vertically. If we had the y right here, then the graph would open horizontally. So x squared means we have a graph that looks like this or this. If we had y squared, that means we have a graph that looks like this or that. Okay, since x is squared, we know the graph could look like this or like that. And we have p, let's do x minus h squared equals 4p y minus 3. I'm sorry, this should be k. So if we just remember this formula, then we can match everything up. And we say that p equals 2, so that means we're going to travel a distance of 2 upward to the focus. So here we're going to move over 2, up 3, and that's the vertex. Then we're going to move, since it's opening vertically, this is moving vertically to the focus. If we have a parabola that opens like this, the focus is in there. If we have a parabola that opens like this, the focus is there. We would never have something where the focus is outside of the parabola. So if that's the vertex and the parabola can either go up or down, then we know that the focus has to be on a vertical line here. We're going to move up 2 to the focus, and then the directrix is the same distance in the opposite direction. And then from there we just can estimate the shape of the graph where we're trying to get a point equidistant from there, from the focus and the directrix. And if you estimate one on that side, we get one on this side, then we can draw the parabola. Alright, pause the video and try that one. So we know that it's moving, the vertex moved left 3 and up 2. We moved left 3, up 2, and because the x is squared, we know it's going to open vertically, like one of those, and the p value is 3. It's positive, so that means we're going to move up. Also, we're going to move down 3, 1, 2, 1, 2, 3, to the directrix. Then we can estimate a point here. And we want this distance to be equal to that distance. And we have the parabola like that. So this one is different because we have y squared, but we also don't have the right form here. We need y minus k equals 4p x minus h. Since y is squared, we know the parabola can open horizontally. And we also don't know p, so we have to say that 4p is equal to 8, so p equals 2. Now we can graph. And we're going to move up, move down 1, right for the vertex, since p is 2 and we're going to move the focus is horizontal on a horizontal line, then we know we're going to move 2 to the right for the focus and 2 to the left for the directrix. Then we pick a point that looks to be equidistant from the focus and the directrix. pause the video and try that one. And we see that y is squared, so that means we can have a parabola that opens horizontally, and 4p is equal to 16, so p equals 4. Here we're going to move vertically 3 for the vertex, and then we're going to move horizontally to the left 4. 3, 4. This tells us that we have to move positively to get to the focus. So I'm going to move 4 to the right, and also 1, 2, 3, 4 to the left for the directrix. Then we need a point that is equidistant from each. This point has to be equidistant from the focus and the directrix. We could get one on both sides. Alright, and pause the video, try that one. Oops, that should be a 4p. So we know that 4p is negative 2 and p is negative 1/2. X is squared, so the parabola opens vertically. And we have 3 to the right and 1 down. 3 to the right, 1 down is the vertex. From the vertex, we're going to move down 1/2. This is the distance and direction to the focus, and it's negative. We know the focus has to be along the axis of symmetry, so we're going to move down 1/2 and up 1/2 to the directrix. And then we need points that are approximately equidistant from the focus to the directrix. Alright, pause the video and try that one. Since y is squared, then we know it could be it must open horizontally. It could go that way or that way. And 4p is equal to negative 4, so p is negative 1. Since p is negative, we know it has to open to the left. And vertically, we're going down 2 for the vertex, and we'll move right 3 for the vertex. So down 2, right 3. Down 2, right 3 is the vertex. We know the graph has to open to the left, so this p-value means move to the left, and the directrix is to the right. Choose a point approximately equidistant from the focus to the directrix. And we'll stop that lesson there.